Hello, this is the group quiz that we took on Friday in class, and so if you didn't do well on that quiz, here's a chance for you to make up some points. So we're going to go through each of these problems, and so take good notes, write down your answers, and show the work. Alright, so this first problem with saving money, Julia starts her account with $325. Now think about that. She starts the account with $325. That's the initial amount that she puts into the account. So right away, I should be thinking of writing an equation where y equals mx plus b, where the initial amount, or y-intercept if it was a graph, would be right there. So 325 is the initial amount. Alright, so next I just need to know what the slope is, or what the growth rate is. Then I can finish this equation and use it to get my answer. Alright, so looking at the table, month 7 she has $780. Month 8 she now has $845. So that's an increase of $65. Now let's see if that's a constant increase. The next month is another 65. Yes, alright. So she's adding $65 a month to the account. That's the growth rate. So 65 goes in front of x. The equation is going to be y equals 65x plus 325. So the question is, how much will be in the account after 5 years? All right. Well, 5 years at 12 months a year is a total of 60 months. Now we need to use months because our growth rate is in months, 65 per month. So we're going to go 65 and then multiply that by 60 and then add $325. So 65 times 60 is $3,900, then add the 325. So the total amount in the account after 5 years is $4,225. Now, some students made the mistake of taking the table and they continued the table till they got to the 12th month. So that would be the amount of in the account after 1 year. Then they multiplied that by 5. Now, we can't do that because this is not a proportional graph. It's not a proportional relationship. And the reason it's not is that it doesn't start at 0. It starts at $325. You see, if it wasn't for that, then you could multiply by 5. All right, problem number 2, this fundraising. Here we have two graphs which represent the fundraising for two different clubs, and we want to find when both clubs will have the same amount of money. And if you look at the graphs, they're not quite parallel. So it does look like eventually they're going to cross each other, but it's not going to be till way, way, way out there. So we don't want to solve this by looking at the graph to see where they intersect. And we also don't want to use a table because a table is going to take us way out there as well. We really want to write a rule for each of these. Okay, so let's start with that. We're going to write a rule for this club and write a rule for this club. All right, now the graph does tell us the initial amount in each of the accounts. So for this account up top, it starts with 270. And this account down below starts with 10. So those are the initial amounts. Those are the y-intercepts. Now we can look at the point they give us, which is the time after 1 week. For the club up top, it went from 270 to 280. So they must have added $10 that first week. So X is the amount of weeks. Every week they're adding $10. For the club below, it started with 10 and now it's at 25. So they're adding 15 per week. Oops. So those are the two equations we should use. Y equals 10x plus 270, y equals 15x plus 10. Now, we wanted the equations because we didn't want to solve with the graphs or a table. Instead, let's use equal values. This is really where equal values is so valuable for us, is that we can use them, the equal values method, to solve whenever we have numbers that would just be too cumbersome, too much time to try to do it with a graph or a table. We can easily solve this for x. We would subtract a 10x from both sides, So we get 5x plus 10 equals 270. Okay, now we're going to minus 10 from each side. So we're going to get 5x equals 260. And now I have to divide both sides by 5. When I do that, I'm going to get x equals 52. So week 52 is when both accounts will have the same amount of money. Now to find out what that is, we would substitute the 52 back in one of the equations. I'm going to substitute it back in the first equation because it's being multiplied by 10, which is easy. So 10 times 52, that's 520, then add the 270. So it's going to be $790 in both accounts after 52 weeks. Okay, number 3, the population growth. So here we're given a table, a graph, an equation, and then just a written description. And we're asked to find the growth rate for each of the towns. So that's all we needed to find is the growth rate or the slope, whatever you want to call it. So looking at the town A, from 1979 to 1980, there was an increase of 4,500 people. Now, if you went back and checked between 1975 to 1979, all right, so that's a 4-year span. So if this is a constant increase, which it is, then that increase over the 4 years, if you divide it by 4, it should come out to 4,500. And it does, because 50,000 minus 32,000 is 18,000. If you divide that by 4, you're going to get 4,500. All right, so town A is growing by 4,500 people per year. Now let's look at the graph for B. Okay, so the graph for B, we can do a growth triangle, and you can pick wherever you want. I'm going to pick this little triangle right here. So at year 0, the number of people in town B is 2,000. After 1 year, it has now gone up to 8,000. So the difference between 8,000 and 2,000 is 6,000. So the growth rate is 6,000. It's not 6, because notice that it said this number represents thousands. So you always got to watch out for that when you look at your scales. Okay, the third town, town C. Here they've given us an equation where y is the number of people and x is the number of years. Now, what they did is they tried to fool us a little bit here. They, instead of going y equals mx plus b, they went y equals b plus mx. They just switched them around. So the number in front of x is the growth rate. So this number right here is the growth rate. And notice there's a minus sign. So that town is actually shrinking. It's losing, or negative, 5,200 people. Now town D is growing. Oddly, the same number of people moves into the town each year. 2 years ago, the town had 9,100 people. Now it has 15,500. All right, so that difference between 15,500 and 9,100 is 6,400. But that's a 2-year span. So you got to divide that by 2 to get the growth rate, which is 3,200. So those are the growth rates for each of the towns, and we were asked to identify which town is growing the greatest amount. So that would be town B. Okay, the last problem. Last problem is that we're looking at video rentals, and we're asked how much does one video rental cost? And then we're also asked how many more videos can Gina rent before her card is used up. So she has $84 remaining on her card, so let's keep that in mind. Now looking at the graph, there's a little growth triangle. And that growth triangle shows the amount of money on the card. So as she rents videos, the amount on the card goes down, right? That makes sense. So you can see that the little growth triangle, I'm going to kind of draw it a little bit bigger, all right? The growth triangle looks like this. It goes over by 4, and then it goes down like that. So the amount of money in the car goes down, and it goes down from $98 to $84. So it goes down $14. So 4 is the run. That's the number of rentals. So for 4 rentals, it cost $14. Okay, so I'm going to divide 4 into 14. That comes out to 3.5, but we're talking about money, so add a 0. So according to the graph then, the cost of the video rentals are $3.50 per rental. Okay, and she has $84 left. So divide $3.50, divide that into $84. Okay, so you do that correctly. Let's see, 84 divided by 3.5. I think it comes out to 24 rentals. I don't know, let's see. 84 divided by 3.5. Yeah, it comes out to 24 rentals. So $3.50 is the cost per rental. She has 24 rentals left on her card. Okay, well, that was it. I hope you took good notes so that you raise your scores. And remember, read some books.